This lesson is all about analyzing data, specifically measures of central tendency, the mean, the median, and the mode. And then finally, the second half is going to emphasize ways to display data. In this first problem, we're looking at US presidents and their ages at the time of their inauguration. There's two groups, one from 1789 to 1845 and the other from 1945 to 2000. Each one of these groups has 10 numbers in total. So what we'll do is we'll add up all the numbers, get a sum, and then divide by 10 to find the mean or the average. So for the first set, when you add up all those numbers and divide by 10, you should have a mean of about 58.1. In the second group, same thing, add up all the numbers, get a sum, divide by 10, and we get a mean of 56.8. Again, mean is just another word for average. Another central tendency is median. Median is the middle number. The thing is, you have to put the numbers in order first in order to find out which one is the actual middle. So the first thing we need to do is organize these numbers so that they're in numerical order. I've done this already. Right here you can see the different groups. So we need to find the middle of each one of these. There are 10 numbers, so there isn't one middle number. But if that's the case, let's see, 1, 2, 3, 4, 5. Right, there's the middle of each one. If you don't have a middle number, then what you're supposed to do is just average them together. Like here for this one, the numbers are the same, so the median is 57. Down here, I'm going to have to average them together. The average of 56 and 60 is 58. The next thing we'll look at is different types of data displays. Instead of giving numerical values, we'll show and demonstrate what that data looks like. So the first one we're going to look at is a frequency table. The numbers you see here are a list of the number of people that each of the 23 companies has on its board of directors. So each of the 23 companies provided their number. So it's kind of a confusing list of data. We want to try to make it as easy as possible to read. I think the easiest way to do this is to start a tally. So we might just make tally marks next to each one and go through each of the numbers. Like it starts with the number 3, so I'm just going to do a tally off to the side. Then there's a 5, a 7, a 6, there's another 3, and another 3. We want to be careful to get them all. So it'll look something like this once you go through all the different ones. A frequency table just gives those numerical values. So I can write down that there are 10 3s, 3 4s, 2 5s, 3 6s, and 5 7s. We can then use this to do percentages. I think in your assignment you'll have to do something similar to this, where we'll want to show what percentage of the 23 companies had, for instance, 3 people on their board. To do this, we just take the number of companies divided by the total, which in this case was 23. So for this first percentage, I would do 10 divided by 23, which is 0.435. And in terms of percent, this is 43.5%. So I'll jot that down up here. We could do the same thing. Like, for example, 3 divided by 23 is 0.13 or 13%. 2 divided by 23 is 8.7%. 3 divided by 23, we already know that was 13%. And finally, 5 divided by 23 is 21.7%. So just taking the total number divided by the total of companies for each one. Using the same problem, the same data, let's go ahead and make a histogram. A histogram demonstrates this data the same way, except instead of using percentages or numerical values, it's in a picture. So you see down below, I've labeled each one of the different numbers for number of people, and then on the side, on the y-axis, it's the number of board of directors. So I'd want to show for 3 that there are 10 companies. You'll draw a rectangle, the height of the number. And you can color it in if you want. 4 had 3 people. 5 had 2 people. 6 was at 3 people. And 7 was at 5. Remember, in a histogram, all of the rectangles are going to be touching each other. One other way we could demonstrate the same data is to use a dot plot. Dot plots, you can use actual dots, circles, or you can use X's. It's completely up to you. But you do want to make sure that whenever you draw them, that the height matches the total amount. So for example, like for 3, I've got to do 10 dots on this 3. So there's 3, 4, 5, 6, and 7 should have 5 dots. Another way to display data is with a stem and leaf plot, where in this particular problem, the stem is going to be the tens place and the leaves are going to be the ones place. The question is asking you to make an ordered stem and leaf plot, which means numerical order, for a number of points scored by the basketball team during the 17 and 18 season. This is going to be a little overwhelming just because there's so many numbers and you have to order them. What some students like to do is actually order the numbers as if you're finding the median off to the side first. Or you can just scan through looking for the lowest number and all the way up to the highest number. Whatever you do, though, I'd recommend crossing out as you find them. Looks like the lowest number on the list is 61. So I'll put a 1 there for the leaf. The next lowest is a 62. And there's another 62. There's a 63. And another 63. A 65. A 66, and a 69. And then we'll go to the next one, the 70s. This process continues until it looks something like this, where the last numbers are 100 and 107. So it organizes the data for you so you don't have to scramble and look through. Down below, there's another example of the women's team. What we're trying to do is make a combined stem and leaf plot so you could compare the two. So here's what I got when doing so. A combined stem and leaf plot's a little strange. The right side should look familiar, but the left side actually goes in the opposite order, so from the inside out. So you'll see in my key at the bottom, I show that. So 6 with a line 1, that would represent 61 if it's on the left, or on the right, 1/6 would represent 61. So you have to look in both directions. What you can do then is you can start to make some observations, which is what the question is asking. Do you see any clusters or any outliers in the data? Well, clearly we can see one outlier, and that's a game, looks like a women's game, right here, where they only scored 52 points. I mean, there's literally no other data near it. You can also see some clusters. Looks like most of the numbers for the women's team occurs in the 70s, just because there's more numbers there. And for the men, most of the numbers kind of was right between the 60s and the 80s. So we could start to observe just some things by looking just at the stem and leaf plot as opposed to looking at the data you see up above. Another way to show data is probably the most challenging for students, and that's with box and whisker plots. So we'll spend some time doing some practice with those. For box and whisker plots, you always want to start by finding the median. So it's important that the numbers are in numerical order. For this first example, I went ahead and wrote them all in numerical order for you, so we don't have to worry about that. The middle of these numbers, the middle of the numbers comes right about here. So we have half of the numbers on the right and half on the left. That means my median is 52. I'm going to start to keep track of this in what I call a 5-number summary. These 5 numbers help you keep track of the 5 most important parts of the box and whisker itself. Next thing we want to do is start to divide this up even more. Instead of just dividing it in half, I'm going to divide it into fourths. Those are called quartiles. So on the left side of the numbers, I want to divide the numbers again in half. There are 8 total numbers, so in half would come between the 24 and the 28. That's called quartile 1. So 26 would be quartile 1. I'm going to do the same thing on the right-hand side. There are 8 numbers on the right-hand side. If you cut those numbers in half, we'll get quartile 3. And just like a median, since there's no number right in the middle, I'm going to average those together to get 64. The min and the max is literally just the minimum number and the maximum number. So min being 12, max being 98. All of those numbers on the 5-number summary will be represented in the box and whisker. I think the easiest thing to do is to start with the min and max. The min and max just get dots. So I want to put a dot at 12 and another dot at 98. The median, quartile 1, and quartile 3 all get lines. So let me go ahead and put some lines down for those. I'll do the median first, which is at 52. Quartile 1 gets a line, 26. And quartile 3 gets a line at 64. Then you just connect your box. The min and the max is connected by a long line called the whiskers. So let's talk a little bit about this box and what it means. You can see for this particular box, it's a very large box actually, and it has long whiskers, at least on the right-hand side. That means the data is really spread out. But it's important to note that each one of these parts shows you how much of the data is there. For a box and whisker, there is always 50% of the data inside the box. In fact, there's 25% on either side of that median. On each of the whiskers, there's 25% of the data. So this kind of shows you where the grouping of the data is. So half of the numbers are in the box, a quarter of the numbers are on each of the whiskers. All right, let's do another one. In this next one, this is a table showing high school students who took the college entrance exam all the way back in 1997, and it gives 7 different states. This number is really already in numerical order, but I went ahead and wrote it out anyway just so we could reference it. All right, so not as much data for this one. The minimum is 45. The maximum is 80. In order to find those divisions, let me go ahead and separate the numbers. It looks like we have an odd number of numbers, so I'm going to go ahead and make the median 64. And then I'll cut those in half, 72, and 46. All right, that's all that I need to know to make the box. So the first thing is I'm going to make my dots for the min and max. 45, and 80, then I'll go back and make the lines. I have a line at 64, a line at 46, which is almost touching here, and another line at 72. Connect those. There's my box. There's a whisker, and then the other whisker is just barely distinguishable, very, very short. What that tells you is there's a cluster of numbers right there on the 25% line. So once again, important, we have 50% of the numbers in this box, 25% of the numbers on this whisker, and another 25% on that other whisker that you can barely even see. This number is really clustered together, the only exception being this whisker off to the right. If you'd like to practice another one on your own, example 6 will give you one. This shows some Olympic data and medals, so that one you can do on your own if you like. And we're going to skip to the very last one, and that's example 7. In this one, it refers to a memory experiment that we're actually not going to be able to do as a class, but you can do individually if you'd like. I went ahead and recorded the values of last semester's students and what they received for their memory experiment. I'll give you a link to it in Sakai so you can try it yourself and see where you fall. But for now, go ahead and copy these numbers down onto your paper, and I'd like you to try this yourself. You can go ahead and pause this video just to see how you do before you see me doing anything. See if you can complete the 5-number summary and then the box and whisker plot that corresponds to it, and I'll show you the answers. So push pause now. All right, let me show you the results so you can compare what you did. We had a minimum of 4 and a maximum of 16. Quartile 1 is 9, quartile 3 is 13, and the median was 11. Here's my box and whisker plot. Now, depending on what your scale was, what you labeled your x-axis, yours might look a little different, but it should still be corresponding to those 5 numbers in the summary. So that's the key thing. You want to check those values. 50% of the students from this semester's class was in between 9 and 13. Of course, we did have some outliers. An outlier would refer to something that's really a lot lower than everything else, like that 4. But keep in mind, even though 4 seems really, really, really low, 25% of the students are on this whisker. So 25% of the students scored between 4 and 9. So again, 4 seems low, but there was a lot of students on that end. In addition, 25% of the students scored on the high end here, from 13 to 16. See where you fall if you do the experiment. If you're right there in the middle with those students in the box, or if you fall in one of those whiskers.